All right, in this podcast, we're going to talk about covalent bonding. All right, covalent bonding is when you have sharing of electrons between two atoms. These are usually going to be two nonmetals. And you want the differences in electronegativities between all the atoms that you're dealing with to be very, very small difference. So if you looked at the nonmetal part of your table, you would see that they all have very similar electronegativity values. And when you have a true covalent bond, you're going to have what's called a nonpolar bond, which means that the electrons are shared exactly equally. Down here we have a couple pictures. So here we have, there's a shared bond between two atoms. So you see that the atoms, they have rings, and one of the electrons came from one element and one came from the other atom. Okay, and then when they share, they actually are going to share that pair. So these two get counted for each atom. Okay, you see the same thing over here. So here it's a little easier to see because they're color coordinated. So you see these dark green electrons are belonging to this oxygen, the green oxygen, and then the yellow ones are belonging to the yellow oxygen. Now they share all of these, though, so they're going to share all four. So this is two pairs here that they're sharing. Nonetheless, they're both sharing. All right, how do we name covalent compounds? First, we're going to use prefixes to indicate the number of the elements that we have. Of the first element. Here are our prefixes. So we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And we're going to use these prefixes. There is one little exception, though. Mono, right here, he cannot be used on the first element. So that one does not count when we're talking about the first element. Then we're going to write the prefix, the name of the first element itself. And then we're going to use the prefixes again to indicate how many we have of the second element. Write the name of the second element, and we're going to change the ending to IDE. Looks like I forgot that part on my instructions, but change ending to IDE. Okay? Just on the second element. And you can use mono on the second element, but not the first. All right, so here's some examples. So let's try to name these. So we have 3, that's tri. So we have triphosphorus. Okay, and then we have 5, that's penta. So we have penta, and then this Cl is chlorine, so it would be pentachloride because we changed the ending to IDE. So triphosphorus pentachloride. All right, the next one, we only have 1, but remember we don't use mono on the first element, so it's just going to be xenon. Okay, and then we have, for the second element, we have 9, which is nona. And then F is fluorine, so we're going to change the ending to IDE, so it would be fluoride. So xenon nonafluoride. All right, and the last one, we have CO. So we only have 1 of the first one, but again, we don't use mono on the first element, so it's just carbon. And then the second element, we only have 1 this time, and we do use the mono prefix here. So mon, and then oxygen changes to oxide, so carbon monoxide, very common gas. Okay? All right. So once you know the name, how would you determine the formula of a covalent compound? Well, basically, you just go backwards. Okay? So the prefixes are going to tell me how many you have, and the name's going to tell you what atom or element you're actually dealing with. Okay? So this first question, what is the formula for carbon dioxide? So we have carbon, and there's no prefix, so that indicates to us that we just have 1 carbon. And then we have dioxide. Oxide is oxygen, and we have di, which is 2 of them, so CO2. All right, what's the formula for dihydrogen monoxide? Okay, well, we have hydrogen, so that's H, and it's di, so that's H2, and then monoxide, so we have 1 oxygen, so H2O, very common again. All right, and the last one, pentanitrogen octahydride. All right, so nitrogen, and it has pent, which is 5, and then octahydride, hydride is hydrogen, and there are 8 of them, so N5H8. All right, and that's all you needed to know for carbon bonding right now. Carbon bonding, covalent bonding, you know what I meant.